So welcome back. In this video I'll be showing you guys how to compute the mean deviation for a simple series, and right here on your screen is the formula for computing the mean deviation of a simple series. So we have our usual guy, the summation symbol, which means you add up all the values. So all the values of what exactly are we adding, that's what you have in front of it right here, x minus x bar. And this guy is not new to us. X bar means mean. That would be mean of the series, and x would be the individual values of the series. Then the denominator n means the total data point you have in the series. So MD simply mean mean deviation. But there's something new here, which are these two straight bars we have here. These two straight bars, this and this, what do they mean? So permit me to quickly explain what they mean. Let's say, for example, just like you can see that what we have in between the bars are x minus x bar. So let me use numbers to explain that. If, for example, you are asked to find or to calculate 2 minus 3, we know that 2 minus 3 is -1 or -1. But when the bar is introduced, we have the bar 2 minus 3. These two bars left and right simply means the absolute value of 2 minus 3. The absolute value of 2 minus 3. Now, absolute value simply means the value of 2 minus 3 irrespective of what the sign is, whether negative or positive. So the absolute value simply means we don't care what the sign is, whether it's a positive value or it's a negative value. We just need only the value, and 2 minus 3 should be -1, but since the two bars has been introduced, meaning to find the absolute values of the absolute value of 2 minus 3, the answer would be 1, because the absolute value simply means we are neglecting the sign. So that would mean that the absolute value of 3 minus 2 is also 1. It should be +1, but we don't care about the sign. We don't care about the sign. All we just need is the number. The same thing, the absolute value of 4 minus 6 would be 4 minus 6 should be -2, but when you apply the absolute value, it becomes just 2. So we need just the number, irrespective of whether it's positive or negative. Also, 1 minus 10 should be -9, right? But when you apply the absolute value, that's the two straight bars, it becomes 9. So that's the meaning of these two straight bars in the formula. So we are just looking for the absolute values, or the absolute value of x minus x bar, then we sum it up, we divide by n. Now we have this example here, 2, 3, 4, 5, 6, 8, 9, 10. It's just a simple series of what we call set of values, and you're asked to find or compute the mean deviation of these values. Like I would always say, the first thing is to write out your formula, because you allow your formula to guide you through your calculations and computations. So the first thing we have is the numerator, and right here in the numerator we have summation. What are we summing up? X minus x bar, that is all the x values. This would be x1, x2 up to the final x values. Then you take each of the x values, you subtract x bar. X bar means mean. So that would mean that we would have to find our mean value first before we can start the computations. So to find your mean, the mean is simply x bar equal to summation x divided by n, where summation x simply means sum up all your x values, and these are all our x values, x1, x2, x3 up to the final x. So we just take 2 plus 3 plus 4 plus 5 plus 6 plus 8 plus 9 plus 10, all divided by, then you count the number of data points you have, 1 2 3 4 5 6 7 8. So we have 8 data values. Your x bar is, then we can always bring up your calculator. You can just say 2 plus 3 plus 4 plus 5 plus 6 plus 8 plus 9 plus 10, all divided by all divided by 8. So right here we have 5.875 as our mean. So okay, the next thing, so we found the mean. The mean is a constant while the x is a variable, so it changes. We have the x1, the x2, the x3 up to the last one. The mean doesn't change. The mean for all the values remains the same. So we are going to be subtracting the mean from the variables. So that will be x minus x bar. Then I suggest that to do that, you just come up with a table. So you can call this your x, then you have your x values 2 3 4 5 6 8 9 and 10. Then you can, well, to make things simpler for you, you can just say x bar. Don't forget that the x bar is the same for everything because they all have the same mean. So you can repeat your x bar values. After that, then you move on to the formula x minus x bar, the absolute value of x minus x bar. So here we can have the absolute value of x minus x bar. So that would mean this minus all of these. So you can employ the help of your calculator. So for the first x, we have 2 minus 5.875. You can see according to the calculator we have negative 3.875, but simply because we need the absolute value and not the exact value, but rather the absolute value, we neglect the sign and just write 3.875. So we do the same for the next value. Next value is 3. Here we have 2.875 without the sign. Again, we go for 4. We have 1.875 without the sign. The next would be 5. Okay, let me just write out the values here so you can see where I'm getting them from. So for the values we have 2, 3, 4, 6. Okay, I think I have 5, 6, 8, 9, and 10. So we can move on. So we have for 2, 3, 4. Then the next would be 5. So for 5 we have 0.875. The next is 6. For 6 we have 0.125. Then for 8 we have 2.125. Then we go for 9, 3.125. Then finally we have 10, 4.125. So I can clear this off. Alright, let's move on. Let me remind you of the formula. The formula says that MD is the summation of all the deviations, that is x minus x bar all over n. So we found all the deviations, all the absolute deviations. That is, we call this the absolute deviation, x minus x bar. We call it the deviations of the x values from the mean. You can see x minus the mean, the deviations of the x values from the mean. So we found all the absolute deviations. The next thing is to sum up the deviation according to the formula. Add up all the deviations together. That will be what this summation sign mean. So that's all we need to do right now. Sum up all the deviations. For the sum up, just use your calculator again. 3.875 plus 2.875 plus 1.875 plus 0.875 plus 1.25 plus 2.125 plus 3.125 plus 4.125. Altogether, the total deviation is 19. So our MD is 19 divided by the total number of data points we have. How do we get total number of data points? You just count. These are our data points, so we just count 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 number of data points, so that 19 divided by 8, and our MD is, bring back our calculator, 19 divided by 8, which means our mean deviation is 2.375. As easy as that. I'll see you in the next video.